Preston, Charlie, Alexis. Thank you. That should be it. All right, well, welcome back, and everybody at home, welcome back. Glad you guys are awake and with us right now. How was spring break? Good. All right. Glad to hear that. It did feel a little short, yeah. How's spring break in everybody in here? Good. How's it waking up this morning? Early, getting to school. I know I hit the snooze button a few times, so I had to work hard to get here on time. Breaks always do that to me. They always throw off my sleep schedule. I don't know if that happens to any of you, where I get in the habit of staying up later and sleeping in, and then school starts back up and I have to wake up early, bed earlier. It just does not work well. So I'm glad you guys made it here. And we're gonna jump in. We'll kind of ease back into things, starting off with just a problem that we were working on last time before we left for spring break with Pythagorean theorems. So just as a little hint on this one here, I remember that we had a formula that we were using. A squared plus b squared equals c squared, which is a formula that we can use with the legs and hypotenuse of a right triangle. So why don't we make sure we got some paper out. Some of you have notebooks. Open this up and we'll work through the warm-up problem here. By the way, the LFD is this thing up here. That's the screen that I'm writing. So this screen is advertised, this LFD, this object up here is advertised as having a 66-inch screen. If you remember from our lesson before we went on spring break, when they advertise the size of the screen, they're advertising the diagonal length of the screen. So from corner to corner, that's 66 inches. So we also know that the height of this screen is about 32 inches, about 32 inches tall. What we want to find out is what is the width of the screen? How wide is the screen? We're going to try using this formula to help us figure that out. And then we'll go ahead and measure to see if it's accurate, see if it works. I do have a measuring tape. We can check our answer by actually measuring the screen and see how it turns out. Go ahead and try putting that into the formula. See what you get. So this is the LFD here. We have a diagonal of 66 and a height of 32. So if you need a little help, that's kind of fun when we're looking for the width. So a picture might help a little bit in getting started. Plug in A, B, C. Let's start with C. What should we plug in for C? Oh, we forgot everything. Do you guys remember what these letters represent? A, B, and C. They represent sides of the triangle. But C represents a specific side, a very special side in the triangle. What do we always use for C? Charlie?
The longest side.
Yeah, the longest side. The longest side has a name. What do we call the longest side of the right triangle?
The hypotenuse.
Yeah, it's the hypotenuse. So we want C. I want my highlighter to be bigger than that. Let's see here. That's better. Okay, we want C to be the hypotenuse, the longest side of the triangle. And which side is that? We have three sides. We've got X, 32, and 66. What do you guys think? 66? Longest side? Hypotenuse? Yes, that is correct. Very good. So we want to plug in 66 for C because it's the longest side of the right triangle. It's the hypotenuse. So we're going to plug that in for C. What about the other two sides? All those the legs, and those don't really matter. The order, right? A and B, the order of A and B do not matter. So I'm just going to put X in for A and 32 in for B. Plug that in for the formula and solve. Go ahead and give that a shot. Oh, we're easing back in. I can see the wheels starting to turn. All right. So go ahead and fill that in. Formula. Solve that. We're trying to find how wide is the screen, which is actually this width right here. Let's see if we can figure that out. Hopefully should be getting close to an answer here. All right, so when we plug in these numbers, you should have got something like x squared plus 32 squared is equal to 66 squared. Possibly with these ones switched. That's okay. You can, these two are interchangeable, the x and the 32. So you might have had 32 squared plus x squared equals 66 squared. But as long as the 66 squared is on the side by itself, it'll be fine. Okay, what did you guys get when you squared these? I know I had a few of you working on your calculators over here. Preston, did you get some of those numbers? Yeah, still working on that part. Do you have a calculator there? All right, so go ahead and tell me what is help me out with this one here. What's 32 times 32? 1024. Okay, and somebody else, what was the 66 squared? You get that, George? 4,356. That sound right? Very cool. Thank you. All right, so we got x squared plus 1024 equals 4,356. What do we do now? We want to solve for x. Yeah, Charlie?
Subtract 1,124 to both sides.
Okay. Good. Did you do that? Oh, all right. What did you get? $3,332. Okay. Thank you. And now what do? We just have one more step here. Somebody at home? Close. We're not going to divide. Dividing will cancel multiplication. How do we cancel an exponent? Just needed one more word there. Square what? Not a square. That's x squared. Square root, exactly. Square root. All right, so we're going to do the square root right now. Both sides. So the square root of x squared and the square root of 3,332. And that will give us the square root of x squared is x. The square root cancels with the square. We just get x is equal to the square root of 3,332. And what is that? That's definitely a calculator question. It's not a mental math question. What is the square root of 3,332? Yes?
Rounded or not rounded?
Let's go to two places. I guess two places, and then we'll round it together. So or, yeah, what is it just to two places?
Or 57.72.
57.72?
Yeah.
Okay, cool. Which then would round, if we looked at the 2, right? We look at the 2 here, does that tell us to round up or stay? We're just going to stay. So we'll just, that'll be like 57.7. So that's 57.7 inches. So let's see how accurate that is. And because I do have a measuring tape, and I verified that the diagonal of this screen here is, in fact, about 66 inches. Right, so from corner to corner, there to there, that's 66 inches. The screen is about 32 inches tall. Right here, that's 32 inches. The question that we were answering here using the Pythagorean theorem was, how wide is the screen? We predicted, according to our formula here, that it should be almost 58 inches, just under 58 inches wide. So let's see how accurate that is. Opening up stuff on my menu here. And yeah, can you see that there, Carlos? Yeah. Does it look like it's just about 58 inches, just under 58 inches? Sure is. Okay, so yep, math checked out. Screen is just about 58 inches wide. Pretty cool. Math, it works. All right. So that was the warm-up. It's okay to take a little extra time on the warm-up today because our brains were off for a week and we needed some time to warm up here. So today we are going to start looking at a new topic. Not entirely new, it's connected to what we were just doing. It's about a special right triangle. And it's called, this one is called a 45, 45, 90 triangle. Okay, so we're going to take some notes on this. So let's see. Special right triangles, 45, 45, 90. Now, for this one here, we're going to start with a square. Actually, probably even just, let's do a rectangle. I want an exact square. Let's see if I can get it to be. Too big, too small. There we go. So let's say we start with a square. What I want to do is I want to cut this square in half. Along the diagonal. When I do that, I'm going to get a special, what we call a special right triangle. This is special because it is exactly half of a square. So this triangle is half of a square. Now I'm going to say that each side of the square is 1. All sides of the square are the same length, so that means that all of the sides are 1. What about the angles? Actually, maybe even before I get into this. Okay, we've got all the sides of a square are 1. All sides are 1. What about the angles? What are these angles? How big are they? How many degrees? Checking the chat at home too. It'd have to be bigger than that. You guys remember like acute angles, obtuse angles, all the different sizes of angles and stuff? So when you look at like this angle right here, how big is that angle? It's a special one. Yeah, you got this. 90 degrees. You guys remember that? Right angles? 90 degrees. All of these are 90. Right? Get some feedback here. Yes? This is remembering this, 90-degree angles. Okay. So we got 90-degree angles. All of these are 90-degree angles. Now what happens when we cut this triangle in half like this? How big is that angle? It is acute. We actually know exactly how big it is. Because we cut the triangle in half.
45.
Yeah, it's going to be 45 degrees. What about this one up here? That's the same thing. Very good. This is also 45. So that means that when we cut a square in half, we're going to get a special triangle like this, where these two sides are the same length. They're 1 and 1. And these angles are 45 and 45. And this is 90 degrees. What I want to figure out is how long is this third side of the triangle? I want to know how big that side is right there. We're going to use Pythagorean theorem to help us figure that out. Before we do that, I just want to point something out to you guys. The name up here, the 45, 45, 90, that's referring to the angles in this triangle. The angles are 45 degrees, and 90 degrees. And we know that because it's half of a square. You start with a square, you cut it in half, you will always get these angle measurements. And because it's taken from a square, these two legs will always be the same size. Right? If this is 1, then this side is also going to be 1. Now, what about the hypotenuse? You guys figure that out? The hypotenuse is going to be x squared, and the legs are both 1. So 1 squared plus 1 squared equals x squared. What's 1 squared? 1 squared is just 1. So that means we've got 1 plus 1 is equal to x squared. Here comes the $1 million question right here. What's 1 plus 1? That's the iconic math problem right there. I know you all know it, so. 1 plus 1 is? Yes. 1 plus 1 is 2. So we get 2 is equal to x squared. And then what's our final step here? How do we get rid of the exponent? And do the square root again. Okay, so we're going to get the square root. I'm going to change the order, if that's okay. Square root of x squared is equal to the square root of 2. I just changed the sides in the equation because I like to see the variable on the left personally. Okay, and we get x is equal to the square root of 2. That cannot be simplified, so we're just going to leave it as the square root of 2. So that tells us that the third side of our triangle here is the square root of 2. So if this side is 1, if the legs are both 1, then the hypotenuse is going to be the square root of 2. We call this a 45, 45, 90 special right triangle. With me so far? Okay, cool. Let me show you a little something here. I'll put it up on the screen here, and we'll see what it looks like. Okay, cool. So here's that triangle. 1, 1 squared, 1, 1, and 1 squared of 2. Now what do you think is going to happen if I change the size of the square, but we keep all the angles the same? Basically, what I'm doing is I'm scaling the square itself. What happens if we use a larger square or a smaller square? Oh, that's nice. All right, so like I could scale this up so that the legs are 2. Take a look at the triangle. You notice. Any observations? Maybe let's draw a few of these in your notebook. So just like on your page right there, let's just draw in a few of these. I'm gonna give you a few different numbers to fill in. So this one is we've got 2. The legs are 2 and 2, and the hypotenuse is 2 square root of 2. All right. So you just do a quick little sketch. You know, you can draw a triangle. Both of the legs are 2, and the hypotenuse is 2 square root of 2. And I'm going to try making it bigger again. Let's try 3, I guess. So you can put this one in your notebook. So now I made it, it's a larger square. This would be a square where the sides are 3 right? 3, 3. And then the hypotenuse is 3 square root of 2. What do you think will happen if I make the legs 5? If I make this bigger so that the legs are each 5 inches. How long will the hypotenuse? If I make this bigger so that the legs are 5. What if I make these numbers here 5? Yeah, very good, Seth. It's going to be, the hypotenuse would be 5 square root of 2. Let's go ahead and try that. Ooh, too far. Right there. Now you'll see that if I make the legs 5, the hypotenuse is 5 square root of 2. You guys see the pattern forming here? This pattern is what this lesson is all about. The special right triangle is to be able to identify the pattern in this specific triangle. Okay. So without having to write it down, if you just kind of watch like this, watch the number on the leg here. I'll try to stand out of the way. Watch the number on the leg, the numbers on the legs, and this number here in front of the square root of 2. You notice that they're always exactly the same. Right? No matter what size this triangle is, the legs are always the same. And the hypotenuse is always exactly the square root of 2 times the leg. Right? Okay, so those are two patterns that you should see in this, is that the legs are always the same, and the hypotenuse is always the square root of 2, is always the leg times the square root of 2. Now that's a very useful shortcut so that you don't have to go through all the work of the Pythagorean theorem when you're dealing with a 45, 45, 90 triangle. Now you can still use the Pythagorean theorem, of course. It still works, but it's not necessary, I suppose. Let me switch back over to here. So all I have to say, if I were to draw in a few of these, right? We had for example, 2, 2, this would be 2 square root of 2. And if this was 5, then this would be 5, and this would be 5 square root of 2. What if I gave you this triangle here, and I told you that this was 7 square root of 2? How long are the legs? Very good. So each of the legs there would be 7. We can get that just by noticing the pattern in this triangle. On the homework, you're going to be taking advantage of this kind of pattern to find missing sides in the triangle. So they'll tell you one of the sides, and then you need to find some of the other sides using that pattern. Let's see here. So it's, for example, let's say I gave you this triangle. I told you that this side here was 10. And that's it. So Carlos, how long would this side be, the other leg? Also 10. Very good. And then Aiden, hypotenuse. Is that? Yeah, 10 square root 2. Okay, so you just follow the pattern there to be able to find some of those missing sides. And the good news is that you can do a lot of this work without having to go through the Pythagorean theorem and all of that other work. So, okay. Why don't we take a minute to let you try some of those problems out, and then I might have some more strategies, some more tools that you can use to help you with that. But for now, give you a few minutes to try out the delta math. This delta math here. Okay, goes there. So homework 21, you still have until this Friday to finish up homework 21. That was from before spring break. Homework 22 is the new one for today. You also have until the end of this week to do homework 22 and for full credit. Still be available after that, but for reduced for late credit. So homework 22, there's a couple of review problems just on the Pythagorean theorem, just to keep you sharp. There's only 2 of those problems. And then there's 10 problems of these special right triangles. So when you get to the special right triangles, you'll see something that looks like this. I wonder if I should have. That's okay. Like on this one here, if this leg is the square root of 6, this is the square root of 6, how long is the other leg? At their screens, which is good. Hopefully working on your homework. But remember that the legs are always the same length. So if they tell you that this leg is the square root of 6, it means that the other leg is also square root of 6. Probably, if you see any problems like this one here, you're probably going to need my help, or not my help, but you're going to need a little bit more information. So I'll take care of that in the notes here in just a minute. There's a little bit of color to draw your attention to the specific pattern there on the triangles. Okay, and the two patterns, you should notice that the legs are always the same length, and that the hypotenuse is always equal to the leg times square root. Okay. Any questions on the homework so far? Any of the problems are any of the problems a little tricky? I imagine I can think of two types of problems that might be tricky right now on the homework. Mostly having to do with problems that already have a square root. Some of them already have a square root. So kind of go over one more thing here with you guys. So all 45, 45, 90 triangles are similar. And I mean that in the technical math definition. In terms of the technical math definition. You guys remember we talked about similar triangles recently? I say recently, I think it was like 3 weeks ago. Because last week was spring break, 2 weeks ago was Pythagorean theorem, and maybe 3 weeks ago was similar triangles. So it's been a little while. But all 45, 45, 90 triangles are similar, which means that you can write a proportion. Now let's see how that can help us. Let me get a snapshot of this problem right here. Do I want to start with something that's like that? Because that's going to be, I don't think I want to start with that one. Save that one for later. That one's too simple. Yeah, I can just make it my own example too. It's going too slow. All right. So let's say that I wanted you to find, let's say that the triangle that they gave you was this triangle here. And let's say that they told you that no, it's going to be, we're going to have to do that, aren't we? Well, let's start off with one of these. So like the ones where this is like square root of 6. I guess we could do that. Let's try that. Let's say that they tell you that this side here is square root of 6, and they want to find, let's find both. Let's find x and let's find y. Let's find out how long is the leg and how long is the hypotenuse. On the math, delta math, you only need to find one of them, but I'll show you how to find both, just in case. And of course, this is a 45/90. All right, so starting out with the easier one, which is x. If this leg is the square root of 6, how long is the other leg? Help me. I need to know how long the other leg is. Sort of. The 6. Square root of 6, yes. So if this leg is the square root of 6, and the other leg is also the square root of 6, those two legs are always going to be the same. Now, what about, I guess I should be showing you the proportions here. So let me show you the proportions here. So this is the triangle that I gave you, but what I want you to think about is the original triangle, right? The original triangle that we talked about is where the triangle was 1, 1, square root of 2. This was the kind of the original triangle, right? 1, 1, square root of 2. That's the first one. Okay, this is like our base triangle. And we can use this triangle to write a proportion with this triangle. You guys remember how that works? We make an equation with two fractions and we sort of match up sides with this. We make a fraction using matching sides. For example, we could do the square root of 6 matches up with the 1. So we put the square root of 6 over 1 right here. And then you could do x over 1 right here. So you do the square root of 6 over 1 and then x over 1. You guys have to match up the yellow sides and then match up the blues, make a fraction using the blue sides. And then you can solve that proportion by cross multiplying. Now, of course, in this case, when you cross multiply, In this case, when you cross multiply, I think when I could do the highlighting now. I already did that. When we cross multiply here, we're going to get 1 times x x, and the square root of 6 times 1, which is the square root of 6. And you get x is equal to the square root of 6. It's a little bit longer. It's a little bit longer than the other way. Than just knowing, oh, hey, they're the same length. Square root of 6, square root of 6. However, when you're working on trickier problems, this is a foolproof way to know how long the other sides are. For example, if we want to know what y is, I highlight that. That's going to be the green side of my triangle. So we can make another proportion using the yellow sides and the green sides. So if I wanted to use the yellow sides and the green side, that would be square root of 6 over 1, the yellow sides, is equal to what? Would be the fraction using the green sides. Is this making sense? Or am I like on like a completely different planet here? Do I need to change gears? How is this? Confusing? Is this confusing? There are other ways to do this. I can show you a different way to do this. Make more sense. I'll still finish this example here. But if this is, tell me if this is not making sense, because I can show you a different way. Or tell me what the green fraction would be. So if we do square root of 6 over 1, that's the yellow. Square root of 6 over 1. What's the fraction using the green sides to the triangle? Alexis, do you have any thoughts? Yeah, there you go. You knew it. Y over the square root of 2. Perfect. So we got the square root of 6 over 1 is equal to y over the square root of 2. And then we would cross multiply. What's 1 times y? Y, okay. And then what is the square root of 6 times the square root of 2? It is also a square root of something. What do you guys think? Square root of 6 times the square root of 2. This one's a mental math. Your calculator won't tell you this one, actually. For this, all you need to do is remember the square root of 6 times the square root of 2. All you need to do is multiply the numbers that are on the inside, combine those. So it's going to be 6 times 2 is 12. So it's the square root of 12. Square root of 6 times the square root of 2 would be the square root of 12, which can be simplified. So we're going to break it up into 2 square roots again, but differently. So 6 times 2 is 12, yes, but what other numbers multiply to 12? What's a different way we can break that up?
4 times 3.
4 times 3, very good. And the reason we want to break it up this way is so that we can simplify the square root of 4. What is the square root of 4? So we're going to get 2, and then the square root of 3. That is what y equals. Y is equal to this 2 square root of 3. So here's x. This is our answer for x. This is our answer for y. This is the new homework from this week. I'm working. There is a homework from last week. Well, not last week, I guess 2 weeks ago. Last week was spring break. But there's a new homework from today. Homework 22 is the new homework for today. Okay. Now, if you use these proportions, you should be able to solve just about any, you should be able to solve any problem in the Delta Math homework on homework 22. There is one other type of problem that you might run into that's going to be a little tricky. And it's this one right here. So just let me show you how to tackle this. And then we'll be good to go. All right. So remember that we can draw sort of our reference triangle. And in our reference triangle, remember the legs are 1, 1, and then the hypotenuse, what's the hypotenuse? 1, 1, and then square root of 2. So you want to have that kind of memorized. This is the special, this is like your reference triangle. Call this reference. The letters are looking similar. This is a reference triangle. Okay, and then we can color code like all the sides so we can easily write proportions, right? We've got the legs and then the hypotenuse. And you notice that there's no information here on this yellow leg here, and they're not even interested in that. So we're not going to end up using the yellow legs here. But we can write a full proportion just using the blue sides and the green sides. We can write a proportion just using the blue and the green. We've got blue, we've got green. We're going to set those equal to each other. So what is the fraction? What's the blue fraction? going to be. Either way, I mean, just it's going to be a fraction using the blue side. The order doesn't matter yet. Carlos, what's our blue fraction? X is part of it. Not a square, but there's two. Yep, one is part of it. So we want to make a fraction using those. So what do you want on top? What should we put on top? Sure. The order doesn't matter yet. Okay, you can do x over 1 or you can do 1 over x. Okay, so we're just making a fraction using the blue sides right here and here. But now that we've done x on top, when we do our green fraction, the order does matter. Remember we put x on top for the blue fraction? That means we need to put the square root of 5 on top for the green fraction. Okay, so we're going to put square root of 5 on top. The green fraction, what goes on the bottom? What is it? Square root of 2, yes. Square root of 2 on the bottom. So that's going to be our green fraction. And then we need to normally what I would say is cross multiply, although in this case, it's going to take us longer. It's kind of funny. Do you guys want to, can we skip the cross multiplying stuff? I just want, see how over here we've got x over 1? That's really just x. So actually, this is already solved for us. X is equal to the square root of 5 over the square root of 2. What I wanted to show you on this problem here that's different is that if you look at the instructions, they specifically say find the length of side x in simplest radical form with a rational denominator. That means that we can't have any square roots in the denominator. So we need to get rid of the square root of 2 on the bottom. There's a little trick for that I want to show you guys. And this trick, this is what we call rationalizing. Rationalize the denominator. Rationalize the denominator. So what we're going to do is, it's kind of like when we're getting equivalent fractions. I want to get an equivalent fraction with a different denominator that is not the square root. So I'm going to multiply by whatever that square root is. Okay, so the square, this is a square root of 2 on the bottom. I'm going to multiply by the square root of 2 on the top and the bottom. And it's going to give me an equivalent fraction, a new fraction that's equivalent, but it's going to have a rational denominator. And you'll see how this works here in just a second. It goes super quick. And once you get the hang of this, just multiply by this square root. It's really not that bad. Because remember, when you multiply square roots, all you need to do is multiply the numbers inside. So what is the square root of 5 times the square root of 2? Square root of 10. And what's the square root of 2 times the square root of 2? square root of 4, which can be simplified. Well, I'll write it just so we, and then we'll simplify it. Square root of 2 times the square root of 2 is the square root of 4. But that can be simplified. So this it's going to get rid of the square root. What is the square root of 4? It's just 2, exactly. Very good, Charlie. All right, so we got the square root of 10 on top, and we've got just 2 on the bottom, and that is our answer. Square root of 10 divided by 2. And that's what we would type in to delta. Questions on that one? Let's see another example of that. Yeah, I'll probably find another one here. So over here, though, let me just square root of 10 divided by 2. Will this one work for us? No, because that simplifies already to 2 square root of 2. So that's not good. Ooh, that'll work. Yeah, I like this one. All right. We want to find the length of side x in simplest radical form with a rational denominator. And we are going to have to rationalize the denominator again. So start by drawing your reference triangle. 1, 1, square root of 2. You should get like sick of drawing this triangle. Draw that triangle in every problem you do. It will help you in the long run, trust me. And if you have highlighters, I do recommend, just color code the matching sides. It'll make your life easier when you're writing your proportions, because when we write our proportions, we're going to match up the sides. And if we put x on top again, get this nice situation where it's really just x over 1, which is just x, so we don't need to cross multiply. Am I going too fast? Looks like. Is okay? So we could do like x over 1 like we did last time for the blue fraction. X over 1 is equal to what? What's the green fraction? Yellow doesn't help us because we don't know. Green fraction. You got there, Arcana? You know what the green fraction would be? What? 2 square root of 6. Sorry. 6 over, yes. So 6 on top, and then the square root of 2 on the bottom. So remember, because x was on top, 6 also has to be on top. So it's going to be 6 over the square root of 2. And then we're going to cross multiply. Well, yeah, actually, we can skip on the cross multiplying step here. We've got the blue sides were x and 1. Green sides were 6 and the square root of 2. And so we're going to get x is equal to 6 over the square root of 2. Now, what do we need to, we need to multiply those because we do not want a square root in the denominator. Our answer cannot have a square root in the denominator. So we're going to get an equivalent fraction by multiplying by something. And this is what you just need to practice. What are we going to multiply? Yeah, square root of 2. Just basically copy whatever that is. If this is the square root of 2, we're going to multiply by the square root of 2. Now, this one's a little different. This is not the square root of 6 times the square root of 2. It's just 6 times the square root of 2. So we don't combine those because they're not both square roots. So this is not the square root of 12. Yeah, just to be very clear, this is not the square root of 12. The reason for that is because the 6 is not under a square root. What this is it's just 6 square root of 2. 6 times the square root of 2. That's it. Now on the bottom, in the denominator, the square root of 2 times the square root of 2, those are both square roots. You can multiply those, combine those. So what is the square root of 2 times the square root of 2? Square root of 4, which simplifies. 2. And this part's fun. We can actually simplify even one more time. Because outside of the square root, we've got these whole numbers here, 6 divided by 2. What is 6 divided by 2? It's 3. So that would be 3 square root of 2. And that's our answer. Just highlight some of the things that we did here. So square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2, and then 6 divided by 2 is 3. Okay. That help? Well, take some time to work on the homework. With that, you should be able to solve absolutely any problem on the homework. That covers everything. As long as you can write a proportion, and this is the hardest type of problem you'll have to do, where you have to rationalize the denominator. You don't have to do that on every problem. There's only some problems that you need to do that. So, all right, take a minute, work on the homework. If you have any questions, feel free to just call me over and look at what you're working on. about 10 minutes to work on the homework right now. See this. Everybody doing good at home there? Any questions? Any questions on Zoom?
Yeah, so it's like the connection is off or something.
It was a little laggy this morning before school started too. I was working on some stuff. Maybe it's just gonna be one of those slow days.
All right, you guys. Welcome back. I hope that you have a great day today. First day back from spring break. Good luck with all your classes. I think we only have like 8 weeks left or something like that. So keep up the good work. See you later. Have a good day.
You have a pencil sharpener?
What?
A pencil sharpener?
Very good. Okay, everybody at home, I will see you guys later. Have a great day.
Floyd Katina. Donnie. Bill. Oh. Nevaeh. Nicole. Us. Josh. Seth. Jasmine. Vince. Granny. Again. Now. Hang on, you guys, I'm getting all this technology going and I've got to get into the meeting and co-host and do all that. I'm not in yet. Taurus. Yeah. Co-host. Yes. Okay. All righty. Okay, I think we're set. Welcome back. So let me see who we have here. All right, I've got Nadanine, got Emilio, I've got Josue, no, Christopher, and Nicole, Michael, and Ashley, and Aria, Amadi. Very good. Awesome. Okay, hope everyone had a nice break and got out of the house a little bit. Things are starting to open up a little bit now, and we're not quite so restricted. Restaurants are starting to open and you can get some places, so I hope that happens. Get out of this monotony of being stuck at home and all that. So we got a couple things to cover today. And so it's been a week since we've done anything academically in here. There were no assignments over the break. So let's talk about where we left off and just talk about it, okay? We did some notes, we took some vocabulary, all on the world after World War I. What's going on in the world after World War I? What we discovered is that based on the Treaty of Versailles and how they were going to wrap up World War I, Germany was not treated very well. Germany was made to sign a guilt clause. Germany was made to tear down all of their industry that had to do with making military supplies. Germany was forced to pay reparation payments to France and Britain. So Germany was in a hard, difficult place. And we saw economically, we talked about words like inflation. In Germany, prices were high, inflation, things going up, 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 okay? German people couldn't afford it. They were printing money for people, which certainly didn't work. So Germany was in a bad place. But then the United States decides it's time to help Germany out, and they talk about the Dawes Plan. And you guys did that triangle in your notebook, okay? And in that triangle, we saw that the United States started sending money to Germany through loans and investments. And Germany's industry started to build and recover from World War I. And Germany started to do okay economically. Things were going a lot better. 1923 to 1928, this Dawes Plan was working. Now, based on the triangle we did, so the United States was investing in Germany. Germany was rebuilding. Germany had money. Germany was now able to pay France reparation payments. Payments for damages in the war. France, having money, was able to pay back the United States loans. So this Dawes Plan was working out. It was satisfying a lot of economic needs. Okay. With that, there was hope in the world. There was hope that things were coming out of economic problems, and maybe we could have worldwide peace. So there were a couple things that happened. First of all, this Treaty of Locarno. France and Germany signed this Treaty of Cooperation. France and Germany had always been enemies, never liked each other. But they said, you know what, maybe now's the time to mend all those fences, if you will. So they signed this agreement. The rest of the world says, hey, if Germany and France can agree to peace, why can't the rest of the world? So that Kellogg-Briand Pact was signed by almost all countries in the world, agreeing that worldwide peace is the way to go. The problem was they were only signatures. And signatures can be broken. And we're going to see today that they start to be broken. And this feeling of peace begins to break down. Okay? So that's where we kind of left it. And 1929, the United States stock market crashes. And when the stock market crashed, this Dawes Plan goes to heck, and no one has any money to invest, can't loan money to anybody. That flow, that triangle flow of money stops, and the world goes into a depression. Okay? Almost every nation in the world was affected. And we're going to see, because of this depression, because of economic troubles, and because of other things, governments start to adjust. And we're going to start talking today about totalitarian governments. Governments that rule with a really, really strong hand. We'll get to that. Okay. First, though, we're going to do a little review of our notes that we finished up with. So you need your notebooks out. So let's grab those and get them ready. Okay. I'll show you where we ended up on the notes and skip a little space, and we're going to do some sentence frames, think pair shares, whatever you want to call them, and do a little review here. So we've done these before. You need to write the prompt, and in the first one, the prompt would be anything that's not highlighted. A general statement can be made that the Dawes Plan was successful following World War I because. And now there's three options. France was repaid reparations, it kept Europe out of depression, and Germany was able to rebuild its economy. Okay. 1, 2, or 3 of those is correct. Now, if you go to the top here, you're going to see one of these questions has one answer. One of these questions has 2 answers, and one of these questions has 3 answers. So when you're doing this, let that be a little bit of a clue, okay, to help you. All right. So where'd we leave off? In your notes, if you've caught up, talked about the Great Depression, wrote a summary box, and that was the last of the notes. Okay, so now we're going to go down and we're going to review all that with this little think, pair, share. You do not need to write that about the answers, okay? However, the information is there. So take some time and work through these. If you have questions about them, go back to the notes. The notes will help you. All right. All right, Amy, you gonna get going on that? Yeah, let's go. Come on. All right, did you figure it out?
Yeah, so that he signed, that's the original one. He signed it,
Okay.
but I scanned it to you.
You scanned it, so I have
So
that
yeah,
saved.
so
So
go
all I
ahead
have
and look in your email.
to-
I
So
got
all I
this
have to do
picture.
is share that.
Upload that document and should be all those pages. So just make sure you got it.
Yeah,
Okay,
let me check.
just make sure that we don't.
Here's
Okay.
the hard copy. All right, so I'm gonna unshare this real quickly and take a look at an email and I'll get right back to you. There you go.
Oh, wait, no, I think that was just us talking the first time.
Yeah.
There, up top.
Oh, okay, gotcha.
So
All
that
right,
should be it. And then you can just save that
yes,
full document and upload it.
Right.
All right, and
Okay.
then that's your original.
Yep.
With the signature, okay?
okay, thank you very
You're
much.
very welcome.
All right,
Let me know if you need anything else.
I will, thank you.
You're welcome.
Oh, we go back here. Second. All right, Amari. Looking at number one, we know that either that has one correct answer, two correct answers, or three. So for number one, do you think that's one correct or two? Two. Okay, so how about reading number one for us and giving us the two answers you think? Very good. I don't think Mario fist bump, we're not supposed to fist bump, but fake fist bump, okay? Fake, because she's absolutely correct. Now, last period, I had a lot of people who said, Mr. Gavin, how come, what about the depression? What about the depression? Didn't the DOS plan help keep dirt out of the depression? And the reason that's not a correct answer is this, time frame. So the DOS plan is from 1923 through 1928, okay? And then October 1929, what happens? October 1929, what big thing happens? Or you use- I can see that. What big thing happened in 1929, October? The stock market crashed, didn't it? That's the beginning of the depression. So the Dulles plan happens before the Great Depression happens, okay? Which makes the middle one incorrect because it hadn't happened yet. Very good. Let's see here. Michael, did you get number 2? Good job. So read the prompt. Okay, 1929. You think that's the only answer there? Okay, the economic presence of high inflation. Okay. You think that's it? Okay. All righty. Good. Christopher, do you have any issue with what Michael said? So he said 2 of them were correct. Okay, so Christopher thinks that the stock market crash is the only one. All right. So pick this one, Christopher. That's correct. So one answer there. All right. So we know Germany did have high inflation, but the Dawes plan fixed that inflationary problem, 1923 to 1928. They didn't have high inflation anymore. That was solved. But then in 29, the stock market crashes, Great Depression starts, and everybody economically has all kinds of problems. So number 1 had 2 answers. Number 2 had 1 answer. Emilio, how many answers does number 3 have? All right, at the very top, it says, one of these questions has 1 answer, one of these questions has 2 answers, and one has 3, right? There you go. There you go. So Emilio, read the prompt and read that whole thing to us, because it's all correct. Okay, so read it to us.
63 countries signed the Plymouth Protocol and 1928 to improve ineffective
Totalitarian
governments formed in 1920s. Democratic governments collapsed in 1920s and militarism took over Japan in 1920s.
Correct. All 3 of those. Okay. So totalitarian government started, which we're gonna look into today. What the heck's a totalitarian government? We're gonna start figuring that out today. Okay. After World War I, there were a lot of countries that tried democracy. So let's have freedom. Let's have representative government. Let's have all that. But they didn't do very good at it. Democracy wasn't working very well for them. And they were taken over by dictators usually. And finally, we haven't even looked into this yet, but militarism did take over in Japan. A military government takes over. So all 3 of those are correct, but we'll get to Japan later. We're not even there yet. Okay, so totalitarianism. Nicole, I'll ask you a question. If you do something totally, you do part of it or all of it? If you do something totally, the total thing, you do part of it or all All of them. Yeah. So the base word for totalitarianism is total. All right, and that's what we need to grasp and understand. A totalitarian government totally controls the lives of everyone in that country. Okay? A dictator does it. Totalitarian government must have a dictator. And the ones we're going to be talking about are Joseph Stalin, who we've seen a little bit about, Benito Mussolini from Spain, or from Italy, and Adolf Hitler from Germany. And Joseph Stalin. So those are the big three, okay, that we're going to be looking into. They're all a little different. They're not exactly the same. All these dictators rule in a little bit different way on how they achieve things, but they are all considered totalitarian governments. The citizens who live in those countries have to do everything their government tells them to do. Socially, economically, politically. Okay? You can only read what the government tells you to read. You can only write if the government tells you it's okay to write that. You work, you do what the government tells you to do as far as a job, everything. Okay? Totalitarianism. And we're going to find out that a lot of these people fell right in and loved it and said, let's do it. Okay? Which is sort of unusual to believe, but it happened. So I'm going to unshare this. Does everybody have this at home? I assume you do. So for the first one here, we should have said that France was repaid reparations and Germany was able to rebuild its economy. For the second one, the stock market crash of 29, and all of them for the third one. Okay. So I am going to unshare and I am going to set up a classroom assignment. Okay, that's going to be done out of the textbooks. And it's not there yet, but it's going to be here real soon. So just hang on and you're going to see it. You guys here, you can get your textbooks out. You're going to need them. All right, it's coming. So when you open that up, it should be there now. And when you open it up, and let me share a little bit, and I'll just show you kind of what it looks like. As it says in the directions, there's going to be 14 questions, a variety, different kinds of questions like I like to do, some summaries, some multiple choice, some true false, a little bit different variety of everything. Okay. So we're going to work through, and this is totalitarianism, Joseph Stalin. So this is how Stalin initiated totalitarianism in the Soviet Union. Okay. This first part, number 1, 2, and 3, are from the first 3 paragraphs starting on page 454. All right. Information on the first paragraph, information on the second paragraph, information on the third paragraph. Okay. So that's where we start. So the due date on this is today. Okay. So based on period 1, I initially set the due date at the end of the period, but a lot of people in period 1 didn't even come close to finishing. So what I've done is I've extended it to a today assignment. You've got, an hour, basically an hour to get as much done as you can. And then you may have a little homework to finish it up. Okay. So any questions on this, let me know. And that's our assignment for today. So Nicole, your new class. So there's a test, is one textbook. So that's for you to use. You do not need to carry a textbook. Okay. Did I just do that? Oh, God. God. She's my queen.
there a hummingbird up there? It's happened once before. Did I tell your boss that or? No, you don't remember? I think it was January and February. I came in here and I heard loud flapping and I thought it was like a moth up in the light. So I come here right up in this light. Well, it was a hummingbird. What the heck? Took us an hour to get it out. Because you don't want to smash it with something. Couldn't figure out how to lower. Kept running into that A through G poster over there. Right above the door. That's how close it was. And it just couldn't figure out. Swoop down. You're free. Chris, Emilio, Michael, Carlos, Marcelo, Nicole, Emery. Are there any questions about the journal problem? I guess that's a no. It's pretty straightforward, really. I believe I put it in the instructions, but the whole point of the journal prompt is practice writing. So try to do the best that you can. But spelling is kind of hit and miss. I get that some are good, some are not with spelling. But you should get the squiggles right on your Google Doc if you misspell something. Try to use proper case. In other words, the proper there. You all get that, right? MLA formatting is a big one. Don't forget to do it first. Am I loud enough for you at home? Of course, I raised my voice to say that I should have been speaking at the same level. Yeah. Was I loud before I asked that, or? Okay. I think this is a new record for me. I have 4 screens. 1, 2, 3, 4. And that was too much for someone to handle. Did you hear that? Someone bailed. No, not funny, not in the least. There's a timer to show you how much time you have left for journal time. when you're done with the journal, if you want, go ahead and, or if you would, go ahead and log into the Nearpod. Get started with that here shortly. Set a timer so that this is bell schedule. Any of you catch the news last week about COVID stuff? No? It, I mean, without making any promises, of course, it sounds like the rest of your school year will be normal. Because the governor said, barring any massive spikes, which I don't think there will be, we haven't had one in a while. June 15th, it sounds like everything goes back to normal except for these masks, if you weren't looking. So, so it looks like your junior and senior year will be back on track. Unless you like hybrid, of course. How many of you like this? You do? Huh. Me too. I was just kidding. I love it. It's the best thing ever. I'm not a very convincing liar, right? Just to let you know too, once I get into this Nearpod, I did set the timer to end at 1:10, so I'll give you like 10 minutes at the end to kind of whatever it is you want to get ready or unwind. finish up if you need to. Is it pronounced Amory or Amory? Amory. Did you know that you can get a newer Chromebook? I think.
So, yeah, I'll bring it back.
Is that one give you problems or?
No,
I think there were problems at the beginning of the school year when all of you had to take that first iReady test. I went through that whole routine to update your browser, but there were some who it wouldn't update to a certain point. It's like, well, that's great. Because you had to have it here, and they were like, here. Or don't be alarmed. Oh. I guess there's nothing to be alarmed about. That's a very serene deal. All right. So with this Nearpod, I would appreciate it if you took notes, whatever that looks like. I don't, did any of you bring like a comp book or paper or anything? That probably would be the easiest way to take notes, just because if you're constantly flipping back and forth between the Nearpod and your notes, that's going to be difficult. But you definitely want to take notes on this, because the essay that you're going to be assigned is basically going to be apply this to Animal Farm. I'm assuming you all paid attention to Animal Farm. Ever see Monsters Inc? That big slug says your silence is very reassuring or something like that. Okay. It should be a fairly easy essay to write, because we'll talk about the book as we go through, because I want you to make those connections. This is kind of advanced stuff, to be honest. Like, it's certainly nothing that you would usually learn in high school, but I've taught it in the past, and in past experience, kids seem to like this stuff. So the way I look at it, if you're learning and you're actually having some sort of fun, yay, that's like a double whammy. See, this is already weird for me. It's nothing any of you are doing wrong, but you're following along, I believe, with the Nearpod. Yes, in here. But you're looking at your screens, and my instant brain thing goes, why aren't they looking at the screen that I'm looking at? It's right in front of you. So this is awkwardness at its finest. If you are at home, go ahead and log into the Nearpod if you haven't done so already. I did forget to put the link in the chat. But you should be fine anyway, as long as you just put that code in there. Messing with us anyway? Messing with us? Oh, someone logged in as you, or that would be kind of weird, huh? Somebody logged in as you as you're sitting here. Yeah. Especially if the Chromebook is closed, quick timeout. So this gentleman that we're looking at, I believe that picture is of a wax figure. I'm pretty sure about that. Not that it matters, but if you think that's creepy, probably is. Unless you're into wax figures, I think that stuff is weird, but whatever. He was a famous philosopher from the 1800s, and his whole big thing was he wrote a book called The Communist Manifesto, and he's considered to be the father of communism and all of that. even though anyone that reads the book would know that towards the end, he basically pretty much says, I don't think this would ever work. The ideas are sound, but they probably would never work. And history has shown that through, because whenever there's a communist nation, it generally ends badly. And badly is pretty much with what we saw in Animal Farm, right? And the idea basically is that when you level the playing field, somebody's going to rise up with a big stick. That's what happened in the book, and that's what's happened throughout history. Before we start this, just in case you weren't there that day or maybe just forgot, the biggest difference between communism and socialism, and there are many, but there are a lot of people will use those two terms interchangeably, right? You hear a lot of people right now getting all upset and worked up in our world today, worked up about socialism and how horrible it is, but actually what they're talking about is communism. Because if you really pay attention, we've been a socialist democracy in the United States since the New Deal in the 1930s with President Roosevelt. That's kind of how that worked. So the biggest difference, you probably want to jot this down because it's not up on the slides. In communism, there can be no private business. In socialism, there can still be private business. So the analogy or the metaphor that I gave you a month or so, 2 months ago, because I briefly touched on this before we read the book. In a communist nation, the state, the country, whatever, would own Disneyland. In a socialist nation, the Disney Corporation would still own Disneyland. Does that make sense? In both of them, there are elements of helping the less fortunate, both socialism and communism, but that's the biggest difference. So you could live in a socialist country or state, and you could still have private business. Which, of course, private business, is what we'll see in this PowerPoint or this Nearpod, is one of the big staples of capitalism. Communism, no. And that goes beyond business too, even like your home. If you live in a home that your family owns, then that's your land, right? In a communist nation, if they need the house that you're in, they can come in and say, well, we own it, so you're going to go somewhere else. You really don't have a choice in that. That's something that, if you're a baseball fan, research what it was like in Cuba. Maybe it still is, but I think it's kind of lessening now since Fidel Castro died. But back in the day wasn't that long ago, you would hear stories of people leaving Cuba, baseball players, like literally on rafts that they made at home to get out of Cuba and get to the United States. And once they crossed into US land, they were safe. So they would literally risk their lives to get out of there for that sort of thing. Baseball players in Cuba would make the same as everyone else. So a teacher and the best baseball players in the world who played in Cuba would make the same amount of money. And the difference for them would be maybe someone would give them free dinner or something in a restaurant in Cuba. That part in blue is very important to get. If you embrace this form of literary criticism, if you think it's interesting or whatever, it does not promote. Espouse means like promote. It does not promote communism. Basically, you're just looking at some of Marx's writings and you're applying them to a text. But I will say this, that last line where it says Marxists, so Marxist critics believe literature can instigate revolution. Do you believe that? No? So as an example, there was a guy in the 1800s wrote towards the end of Marx's life, but he was a U.S. writer. Henry David Thoreau, this quote's up there above Michael, kind of in the top left window. See that? Go confidently in the pursuit, or what is it? Whatever it is. When I saw that was a Thoreau quote, I'm like, oh, cool, read it. Thoreau was an American writer, and he wrote a book. I'll flip the slide for those at home. He wrote a book, or I mean, I'm sorry, he wrote an essay called Civil Disobedience, where he basically said if your government is doing a lot of unjust things, then it's pretty much your ethical obligation to not obey them. And he got in trouble a lot because of, laws against, or not against, laws that were for slavery. Thoreau was never down with that, because, as you know, until 1865, slavery was legal in the US. So Civil Disobedience is a very interesting and powerful essay. But basically, Thoreau's big thing was if you're going to do this correctly, you don't want to be violent. So why am I bringing this up? That last line where it said can instigate revolution. Gandhi, you've all heard of Gandhi, yes? Yeah. Gandhi used civil disobedience to do his nonviolent protest against the British Empire. And that's kind of how he led the Indian Revolution. And we talked about that when we read Rikki Tikki Tavi, remember? You all remember that, I hope. Where I flipped it, showed you how the snakes were the innocent victims and Rikki Tikki was the British Empire. Okay, so that, and that, by the way, those concepts, that was post-colonial theory, very similar to this. The terms are different, the ideas are the same. Told you that before too. And then when I teach you about feminist criticism, it'll be the same thing there. Same idea, different terminology. Anyway, so Thoreau's civil disobedience was used by Gandhi, and then in the United States in the 1960s, Martin Luther King Jr. was also a huge fan of Thoreau's civil disobedience, and he used that to also have his own nonviolent protest, and you saw how that worked. So if you were confused by that last statement, that's what that's talking about. So these are important key terms to know. Capitalism, that is definitely the main political idea that we have, or economic and political idea or ideal that we hold here in the US. We're not going to talk about these a whole lot yet because the next slides are going to deal with them. Although you will have an activity where you get the match. I wanted to throw that stuff in there just to make sure you're staying awake. So if you look like you're getting tired here, I can only imagine what it's like in the Zoom world. Maybe not. I think this stuff is fascinating, but maybe you do, maybe you don't. I don't. Let me know too, by the way, at home or here, if I'm going too fast at any point. To go back to that idea about how literature can instigate revolution, you ever noticed that, and maybe you haven't learned this yet, and that's fine, but like in Hitler's Germany, definitely in Stalin's Russia, notice that banning books is one of the first things that they do. Yeah. That's why, because they know, oh, no, wait a second. Like I could pretty much guarantee you that you would not be able to spread Animal Farm in North Korea. Because the fear would be that people would read that and go, oh, no, wait a second. What's going on here? Like, let's see what's happening in their country. Scary stuff. One of my students went to China. She was up in Yucca Valley, and it was a family that adopted babies from China. Because in China they can regulate, you can only have like one child. I don't know if you knew this or not. And so the idea is that a lot of families wanted a male baby. Why? To keep the last name going, right? So there have been over the years like a lot of abandoned babies in China, especially like girls. And so they end up in orphanages, and so this family that I had two of the daughters up in Yucca Valley, they would adopt those children. They had like 4 of them, I think, that they had adopted. So they went one year during the school year. And I said, well, journal your experience like that. That could be your makeup work, just write a journal like what it was like. And she said that when she got out, I believe her name was Gracie, or that was the sister. Anyway, she said that when she got off the plane, a lot of her social media stuff was restricted, like immediately. Now, some of you might go, well, stuff is restricted on, sure, it is, right? Because the school district, when you're logged into their stuff, they are your dictators when it comes to that. So if you log in, I know a lot of students want like I'm sure the district would love to hear me calling them dictators, but in this case, it's because you're using their equipment, right? And that includes Wi-Fi. So that's why when I hear students go, hey, what's the district's Wi-Fi? I'm like, I don't know, I don't use it. You probably shouldn't either. Because if you're using their stuff, you're giving them access to your stuff. So that's kind of the way it works, but in a way more extreme level in that even adults. So it wasn't just my student whose phone was blocked, her whole family, even her parents. Like there were certain things, social media sites and things like that were blocked. Now, can they have the internet in those countries? Sure. And China is a communist nation. If you're like, what's the comparison here? You can have the internet in those places, but they're going to pretty much tell you what it is that you're going to go on and what they're going to feed you, feed your head, The big term on this one, because most of these you probably can remember pretty easy, is reification. And that's basically looking at people as a commodity. Your worth is in what you can do for our company. That's kind of the idea. Okay, I think I gave you long enough to get all those terms, yes? Everyone good at home? I'm not seeing the chat box light up, so it looks like we're good. All right, there's your first activity. Hide your names. Got to make sure everyone's on the same page here because you only have 1 minute and 30 seconds to do this. Come on, man. I'm not that boring. Actually, I probably am because I'm not comfortable. "45 seconds. Rather than type, I'll just ask you, when you say it doesn't let you in the Nearpod, are you referring to the full Nearpod, or it doesn't let you answer these questions in the Nearpod? And you punched in the code? Sometimes that hyperlink doesn't work. What device are you on?
Ashley. What device, are you on like a personal device? Are you on your school Chromebook? No one had a problem in here, right? Getting into the Nearpod? Okay. And what is it saying? I'm gonna go ahead and move forward. Is it just blocked or? This is the ridiculous cheap fix, but sometimes it does. Try to just